Beer, I was a connoisseur of the beer and cheese.
Interesting, yeah.
Well, Tim, he's my older brother. He's the manager of the Fayetteville Performance Center at SmartSignal. He's also been the manager of oil and gas at SmartSignal too. Prior to working at SmartSignal, he was a summer associate at corporate finance at AG Edwards. How'd that go for you, Tim?
Well, the summer associates get to do all the good stuff. We're doing a little thing with an outfit you might have heard of called Enron. Project Death Star. It was brilliant.
I don't think we should bring up Death Star right now.
Yeah, you're right. If they just would have done it slightly differently, it all would have been fine.
All right, well, he's also been a process engineer at ExxonMobil for a number of years. He has an MBA from the University of Chicago Booth School of Business and a BS in chemical engineering from the University of Illinois at Urbana-Champaign. What kind of chemicals have you manufactured, Tim, at your stay?
Well, we learned to make many types of chemicals, really mostly for the best.
I really like visiting you down at U of I. We used to always sit in the mobile lab, used to move around all the time creating your chemicals. And
well, you know, it's we figured if you make the chemicals closer to your customers, it's probably for the best.
Well, best way to avoid for anyone finding out is for them not to know about it.
That's the truth. All right, well, like many of the presentations, we have some interactive questions. Does everybody know how to use your spot me device? You know what? Don't even bother learning now. It's the last day of the last presentation. We're just going to tell your bosses that you really learned how to do something good with these spot me devices. All right, over the years, many callers have said their equipment breaks at inopportune moments. Tom and I were wondering, how often does your equipment break down on schedule? You know, Tom, a wise cat once said, if you don't know where you're going, any road will get you there. The Cheshire Cat in our maintenance department says if you don't have a schedule, you'll never have unplanned maintenance.
Well, Tim, if you listen to that cat, let's hope nothing ever breaks down.
All right, well, let's see how the voting's going. So, equipment never breaks down on schedule, and many people don't have a schedule.
That's good to hear.
All right.
Well, move on to the next question.
Move on to our next question. This one's really important to us.
So who helps you diagnose equipment problems? Is your operators, your maintenance technicians, software solution, or radio call-in shows?
Tomas, do you think if we get a good response for number 4, we can raise our advertising rates?
Well, I sure hope so, Tim. I had enough of Milwaukee's best.
Yeah. Voting's in progress. Go radio call-in shows. We're taking this information directly to Nielsen. Okay. Vote's closed. Well, maintenance technicians are up there. One day we'll catch up to the maintenance technicians, Thomas.
Let's hope so. And our last question.
All right. All right. You've heard from many successful SmartSignal customers about many different applications. Based on all of you have heard and based on your own experience, what is the most important output of a successful SmartSignal solution integration?
Yeah.
Please vote.
First choice is dynamic charts. Second one, email notifications. Third, secure data. And fourth one, catches.
Catches, catches, and more catches.
A lot of emphasis on catches, Tim.
I think they're very important. Okay. Vote's closed, and here comes the results. Yeah, a lot of emphasis on catches.
All right, no more Milwaukee's best beer for me.
Okay. All right, so now we're going to move on.
With thousands of sensors and hundreds of pieces of equipment, finding early warning is like looking for a needle in a haystack.
You've heard from many SmartSignal customers who have found early warning, and they have prevented catastrophe and avoided many surprises.
With the SmartSignal solution, you can switch from unplanned maintenance to planned fishing expeditions.
Absolutely. All right. Now on to our first letter. It's from George in Houston.
Okay. George writes us in saying, "Good morning, Tim and Tom. How are our Trout brothers doing? We are operating an old GE Frame 5 gas turbine at one of our oil and gas production platforms. None of our alarms have alerted to any issues, and then all of a sudden the coupling between our gas turbine and compressor locked up. I've enclosed some equipment data from the SmartSignal Availability Performance Center, and I wonder if you can use this data to help us find early warning of coupling lockups."
How nice of George to ask us about our day.
You know, while George is fishing in the Gulf of Mexico, we're here working hard to solve his problems.
Well, Tom, I don't know what you define as working hard, but we've only started to read this letter. Why don't we finish it up?
Well, that's besides the point, Tim. Anyways, let's keep on working hard and finishing up this letter. Whenever our coupling locked up, we sent out at least 2 or 3 guys to shake the Houston out of this gearbox. After enough patience, persistence, hammers, and kicks, it eventually loosened up the baby. Soon enough, we're up and running again. We think early warning reduced the wear and tear on our equipment. Well, Tim, I suggest we look at the report item sent from our SmartSignal Availability Performance Center.
Okay. Oh, here it is. If we look at the data that comes from our APC, we're going to see that the high-speed gear thrust bearing temperatures have been increasing about 20 to 25 degrees above model predictions. Interestingly, it wasn't a constant 20 to 25 degree model prediction. It would be higher for several hours at a time, then go back down.
We also see that our relative high-speed axle position follows the same pattern, and that you shift about 2 to 3 mils positive for several hours at a time.
You know, the other thing that really strikes me, Thomas, is that several days before this coupling lock, that seal outboard temperature was increasing steadily as well.
Tim, correct me if I'm wrong, but isn't the sealing oil a crude-based mineral oil? So when it heats up too much and long enough with all these axle movements, the oil will tend to kind of centrifuge out and form particulates of mud. And can't this cause the gears to lock up?
Sometimes the case. You know, the other thing we sometimes see, Tomas, is that seal oil levels drop when the compressor moves enough. There might be enough restriction in oil flow, or the return lines might get clogged and not allow for proper cooling.
So George, although we cannot tell you exactly when your compressor, your gearbox will lock up, it appears that there are some indications for this early warnings. So Tim, are you satisfied with our response? Is it enough to benefit the greater good of society that deals with gas turbine-powered compressors?
Well, I mean, it's very comprehensive. And, you know, I'd also suggested, George, that during the next time this compressor's down, hopefully not due to another coupling lock, that the gearbox be opened up and cleaned out of all possible buildup. Shaking the Houston out of that component is a good temporary fix, but the best proactive solution may be to clean out all those components.
Well, Tim, I just received an email from George
Oh.
saying that he's used this information to find 2 more couplings on the verge of lockup. They cleaned up, and the residuals went back down and never appeared again.
Put her in the net! Yes! All right. And symbols on those charts. Could you explain all those lines and colors to our radio listeners?
Sure.
Usually color doesn't go that well over the radio, but...
Not a problem.
All right.
As long as you can understand what blue is and green, we should be fine. Blue is the actual values that come in through your historian, and the green line is what our model predictions are based on previous operating conditions. We also see that we have several red X's, which are alerts. And whether it's positive or negative, it's still the same. And we also have, at the top, you can see we have our diamonds, the red diamonds. And after enough persistence of alerts, we'll receive these incidents, and we shall appear to our incident list. The other thing on our charts you'll notice are the blue line at the top, and that's NANs, which are not numbers. So whenever there's a problem with any data coming in, it will return as something like that. And
Well, thanks for that explanation, Tomas. So, you know, I will never forget that blue is true.
well, Tim, the APC even printed out a bunch of these wallet-sized cards, you know, for all the vocabulary on them.
I know, some guy kept giving me those cards yesterday. Anyway, all right, now on to our next letter. This is from a true lover of green power, Barry from Kenwood. Dear Tom and Tim, we operate a fleet of 1.5 megawatt GE wind turbines. SmartSignal solution alerted us to negative residuals on all of our field voltages of about minus 13 volts. 13-volt negative residual. Wind speed was constantly changing. We have never seen this before, and we are concerned our power factor will take down the grid. Huh. That would be true catastrophe. What do you think could be the problem?
Well, Tim, do you think it could be some terrorist attacks by pigeons, crows, or seagulls?
Well, it's always a possibility, but if it's not that, one thing we've learned about wind turbines is that the control system is very complicated. Tom, what are the control modes for the wind farm management system? I don't remember them anymore.
Well, Tim, if I know my GE wind turbines properly, there's a wind farm management system which runs in either a power factor or voltage control mode. Let me BBM Barry quickly from Kenwood to see what kind of mode they're running in.
Barry's always on his BlackBerry, isn't he?
Yeah, he can never walk away from it. It's like his third thumb. Okay? You just got back to me.
Yeah, it's amazing how fast he is with the BlackBerry.
So, it appears that the wind farm management system was enabled, but we were operating in the power factor control mode with the power factor setting of 1. Well, what we ended up doing is we changed it to the voltage control mode and inputted a set point of 141,000 volts. Apparently, there were some modifications made to the wind farm management system yesterday,
Really?
and this got switched.
Yeah.
So, we have changed it, and we should see some improvements after this one.
Put it in the net! Catch! All right. Our next letter, Sarah from Wasila writes to us.
Well, Tim, I heard that you got a pretty good view of the Kremlin from Wasila.
I've heard that too. All right, dear Trout brothers, we operate a GE 7F8 gas turbine engine. As you know, the temperatures across the country start to rise and power plants start to work hard to keep the temperatures just right. Even with all our efforts to control the temperatures, we have steep rises of bearing metal temperature residual on our gas turbine. We have not hit the DCS alarm point yet. We didn't see any change in lube oil temperature or in the other bearing temperatures. And it did not appear to be related to a bad sensor. Could this be an impending failure condition? Sarah asked a lot of good questions.
Sarah, the most important thing to check is that the instrumentation is working properly, which you seem like you already did.
Thomas, what else could possibly cause that bearing to run hot, even when there's no alarm? And what do you think?
Tim, the bearing could have some excessive wear. I mean, we could also have a failure to lubricate. I've heard also that there might be problems with the bearing cooling fans. And let me post real quick on Sarah's Facebook and see what she thinks. Hold on a second, Tim.
All right, yeah, put that on there about the bearing area cooling fan problems. It's
All right.
definitely a possibility.
It's posted.
Oh, yeah. Man, 34 people already like that comment, Tom.
All right.
Oh, man.
Let's hope more.
Yeah, all right. Well, let's move on here.
Hold on, I got a Facebook notification from her. Oh, she wrote on our wall. Great.
Good.
Well, upon further inspection, we found that one of the bearing area cooling fans were not performing correctly.
Oh, yeah.
The operators turned on the backup fans in the area, and the bearing metal temperatures returned back to normal conditions.
You know, Tom, a high bearing metal temperature can break down lube oil that supplies the bearing to the point where it fails to properly lubricate the bearing. If the high bearing temperatures had gone unnoticed, this condition could lead to high vibrations, which could lead to a turbine failure and a possible wiping of bearing that could lead to an unplanned outage.
Well, the cost of this would not be only the expenses of spare parts and labor to repair everything, but also the lost opportunity caused due to being unavailable to run.
Quite considerable.
Fortunately, SmartSignal's catch and constant communication with the customer played a major role in avoiding the solution. Thank you, Facebook.
Yeah, absolutely.
Well, Tim,
You can put it in the net. Catch. All right. Now today our list of platforms from wind farms and combined cycle power plants around the country. Finding the root cause of these problems from all the possible failure modes and instruments is truly like looking for a needle in a haystack. Our listeners use the SmartSignal solution to find early warning and prevent possible catastrophe. Now they have more time to fish. Put it in the net. Catch.
that kind of ends it for now. Let's open up questions.
You can open up for questions. The Trout brothers will be here for a few minutes.
If you want to dial in and diagnose your problems.
Post to our Facebook page, BlackBerry, whatever you feel like.